Hello, everyone. Welcome back to our next lecture, numbers on different bases. Numbers on different bases. Why do we need to learn this? Your students might ask you this question again. Okay. There are several answers you could use to answer your kids. One, in the history, different numbers of different bases have been used, like Babylonia numbers. So that was used in the history for sure. And nowadays, it is used because of the computer. That is why people now nowadays study the binary numbers because of the computer use of the computer. Yeah, so you will know what I'm talking. Okay, so first of all, let's look at the decimal number system we're using daily now. We are more familiar with. Binary is for machine, computer. But decimal, like using the symbol 0 to 9 is for human, for our daily life, like normal people like us. So for decimal system, we know that we need to use the digits 0 to 9. And, I have young kids and I look at their textbook. I see the effort that the teachers try to teach them the base 10, base 10, like this, 12. So they were taught that this 1 doesn't represent 1, actually it represents 10. That makes sense. And this 2 represents 2 ones. Yeah. So in math, because we are all math teachers, then we know that this 1 is 10 because we use it to multiply 10 to the first. Yeah. And this 2 means 2 ones because we use it to multiply 10 to the 0. So we can represent 12 in this equation, was expression. We all understand that. That's not a question. Yeah. Why do we mention that? Because the binary system uses exactly the same way. Exactly the same way. In decimal, when we write the hundreds, the tens, the ones, the hundreds actually, that represents 10 square. So that is why it's 100. And the tens means 10 to the first. So that is the 10th position, and the ones is 10 to the 0. Yeah. And similarly, when we write the binary numbers, so it is like the 10th position, but because binary is based on 10, so you want to multiply the digit with 2 square. And the ones, a 10th position will correspond to 2 to the first, and the ones position will correspond to 2 to the 0, which is 1. Therefore, when we write binary number, it is not like a decimal the number system. It doesn't have 0 or what, it has 0, but it doesn't have like 2, 3, and 9. It only has 1 or 0, 1 or 0 binary. Turn on or turn off, on or off. So 2 stations. That is why we use binary. Okay, and originally in decimal system, 3 will be represented in the binary form as 1, 1. Please don't pronounce it as 11. It's 1, 1, because the first one on the left corresponds to the power of 1, power 1 of 2, base 2. The second one corresponds to the power 0 of 2. So if we add them together, total them, we get decimal 3, but in binary, that means 1, 1. I think you probably already know this, so I don't want to waste your precious time talking too much about this. But I hope, let's see. Yeah. I hope you could learn something new here, which is not usually seen in binary number system. At least when I was in college, I learned binary, but I didn't learn multiplication and division. Although this is so similar to the decimal. Yeah. As I said earlier, different numbers on different bases have used in the history. Here are just some examples: quaternary, based 4, quinary, based 5, octal, based 8, hexadecimal, based on 16. These are 8 and 16, they are powers of 2. Therefore, they are widely used in computer and information like system. They are so widely used. Okay, so remember I just mentioned we can do multiplication and division on binary. So this is multiplication. 1 times 1 is 1, 1 times 0 is 0. Yeah. So we can do multiplication of binary numbers like this. Let's multiply 101 with 11. I put a subscript 2 there to represent this, and this is not a decimal. It's not like 101 in decimal. It is a binary 101. And you can see that the multiplication is so similar. It is almost identical to the decimal multiplication. You also start from right. Use this one to multiply 101, so that will, without surprise, give us 101. And use this like 1 on the 10th position, but before you do the multiplication, you want to switch it left, shift it left by adding a 0 at the end. You can see it's identical to the decimal multiplication. So 1 times 101, you still get another 101. Then again, we're going to do addition. So again, starts from the right. 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is another 1, and the answer is 1, 1, 1, 1 based on 2. So that is a final answer. That is a final answer. Yeah, not too bad because so similar, so comparable to what we are doing in decimal. Okay, how can I? Oh, here, yeah. Zoom is, yeah, still new to me. Sometimes I get lost on the toolbars. Which one should I pull out the tool and which one should I use to get the pointer? Okay, division. We can do the similar thing on similar to decimal numbers. We can do division on binary. Yeah. So we are going to divide. We are going to use 111011. So six digits here to divide by 11 on base 2. Just so identical to what we did in decimal. Look at this. So the quotient for the 1, we can do 1 here, and then you can subtract here, you get 0, so you don't have to do anything here. Then you put that one down here, but that is too small to divide by 1, so you put a 0 there, and then you put another 0 here, 1, 0. It is still not big enough for 1, so you get another 0 there. You keep putting another 1 here. Okay, now it's bigger than 1, then we can put 1 here. We're not surprised because in binary it's only 0 and 1, 0 and 1, 1 with 0. Then you want to do subtraction here. Subtraction here. subtract. Oh yeah, oh, I already have a subtraction here, sorry. So this is not necessary. Okay, then when you do the subtraction, 1 minus 1, good, that is 0. And remember this is the tricky because 0 is not big enough to be subtracted from 1. So we want to borrow. We want to borrow that one here and cross it. Remember that one will be a base. So if we get here, we borrow 1 there. Just give me a second. Then that will correspond to the base, but that is 2 here. Yeah. Because binary numbers are based on 2, so borrow 1 from there, so that is 2. Then 2 minus 1 is 1. So we have 1, 0. Again, we need to pull the last digit 1 down there, so we get another 1, 1. And then we repeat this, we get 1 there, and then we repeat the subtraction, we've got 1, 0. So the answer is we have the quotient. Quotient is on the top. So that is the quotient here. And we have the remainder on the bottom. And remember, all of them are based on 2. So don't forget in your homework, don't forget to put the subscript there. Yeah. Okay, again, you can pause the video anytime you want, and you can go as fast or as slow as you want. Yeah. Okay. Yeah, so we can do the exercise here, and unfortunately this course is all asynchronous now, so but I can definitely show you the example because you're going to do it by yourself anyway. So let's do it. Let's see. For the first one, it is so similar to the decimal. We're going to do the addition. So we will line them up vertically and do addition. Mine lineup is pretty bad, but I try. Okay. Again, we start from the right. So 0 plus 1, here is 1. 1 plus 1 is 2, right? 2, but remember this is just like a decimal, it's based on 10, but you never see 10 in the answer. So we change it to 0 and it's a 2, but it becomes a base. So we put 0 there, we put 1, shift 1 up. Well, carry 1 up, yeah, carry 1 up. Then 0 plus 0 is 0, plus that 1 is 1. And this is 0 plus 0, another base 2, but we just put 0 there and carry 1, yeah, up. So that is the answer. Okay, so that is the first one. Second, subtraction. Again, line up. So we have 1, 0, 1, 1, 1, 1, 0, 1, subtract. 1, 0, 0, 1, 1, 1. Yes. And like before, we are going to do from the right. Do the subtraction from the right. So let's see. This one minus this one is 0. And this 0 minus this one, we borrow 1 here from here. So we cross it, that position. Okay, let me change the color. What is the menu to change the color again? Oh yeah, this is a color. Okay, so we cross this, so that position now becomes 0, but that one will give us 2 here. And cross this 0, so 2 minus 1 is 1. And again, that 0 is not sufficient to minus that 1 again, so we borrow again from the up. So that position becomes 1, and that 0 becomes 2. So 2 minus 1 is 1. And 0, that is 0 minus 0, and that is 0, and that is 0. So actually, we don't need the 3 zeros in the front anymore, so erase it. Then our base is 2 again. So that is the second one. Okay, the third one. Okay. Multiplication. Yeah. 1, 0, 1, 1 multiplies. Remember, line up. 1, 1, 0. And again, we start from the right. 0 goes to every digit, so it is 0. So there's no, just a 0. Okay, the second line, we go with a 1. Again, we are going to shift left. So we put a 0 at the end. So 1 times everything is just the same number. So it's 0, 0, wait, 1, 1, I mean. 0, 1. And the same thing for the third position. We put a 2 zeros there, and we have 1, 1, 0, 1. Okay. Let's move here because we are running out of space. So 1, 0, 1, 1, 0 plus 1, 0, 1, 1, 0, 0. So we add them together again from the right, always from the right. Doesn't matter you do. Oh yeah, when you do division, it's a different story, but for addition, subtraction, multiplication, always start from the right. And when we do 1 plus 1, remember that is a base. So we put 0 there and carry 1 there. And 0 plus 1 plus 1, another base. We keep carrying. And this 1 plus that one, another base. And 1 plus 1. Yeah, so that is the final answer. Okay, 1, 0, 0, 0, 0, 1, 0. 7 digits, yeah. Okay, so we have done addition, subtraction, multiplication. Let's do division. Division. Okay, we probably need more space. Doing division. Okay, so let's see. One, 1, 1, 0, 0, 1, 1, 0. 0, 0, 1, 1, 0. Let's see, 1, 1, 0. Let's start from the left. Doing division, we start from the left. So we have 3 digits here, so we need the first 3 digits, 111, so that's big enough. We put 1 here. Remember in your quotient and the remainder, of course, you can only see 0 or 1, nothing else. And we do subtraction. So 1 minus 0 gives us 1, nothing else. Then we put that 0 down here. Not big enough, so we put 0 here. Then we keep pulling another 0 here. Still not big enough, so we have another 0 there. And we put this one down there. Now this is bigger than 1, 1, 0. Remember, quotient and remainder only has 1 or 0. Since it's bigger, so there's no choice but 1. So it is 1, 1, 0. And you do the subtraction. So 1 minus 0 is, is 1. And how about this 0? This 0 is not big enough, so we borrow. But that is also 0, so we have to borrow from here. The leading digit, so we cross it, that part becomes 0. And we have 2 here. 2 here, then we want to borrow 1 down. So we cross 2, let it be 1, and then we have 2 here. Okay, now it's big enough. 2 minus 1 is 1. And that 1 minus that 1 is 0, so we don't have to write it down. So that is the final answer. Okay. No, we're not done yet. Sorry, I take it back, my bad. We're doing division, we are not done yet. Okay. So we have 1 here, then we just put another 1 down there. Very good, it's big enough. So we put 1 there. Let me change the color, otherwise it's funny. 1 here, and let's cover this. And this. All right. So we put a quotient 1 there, then we have 1, 1, 0. And then subtract. So the right digit becomes 1. Again, we put down the last 0, not big enough. Yeah. Okay, so we are down for the fourth question. For the division, the quotient is 100, 110, and based on 2, of course. And remainder 10 based on 2. Yeah, I think it's a lot of fun to do the same thing we already know about on the binary form. Yeah. So that is a okay. That is a binary numbers. Oh yeah, we have all the solutions here already. So you can read this without looking at my messy handwriting. But I prefer doing it again 1 by 1 so you can see the trick. Because you can see that all the solutions here are just 1 step. Boom, you're done. Huh? But when I go through them with each step, you can see it better. So here are the solutions. And we got the same answer, yeah. But I have walked you through every step, so you should be better prepared for the homework, yeah. Okay, so if we have a number, the same value in different forms, one is in binary, one is, yeah, it is like that. Some toolbar just appear. I try to move it, then I put a scratch there. Okay. So one is binary, one is decimal. We're going to learn how to do the conversion either direction. So this page is about from binary to decimal. Binary to decimal. We sort of mentioned this earlier, if you still remember. So we look at a number in the binary form like this. We always start from the right. You use a digit from the right one by one. For each digit, you multiply the power of 2. Like 1 on the very right, you multiply it by 2 to the 0. And when you do the left, shift left by 1, you do 1 times 2 to the 1. And 0 times 2 to the 3rd. And you keep going, you can see each time the power of 2 increased by 1. At the very end, you total them, you get a decimal value of this. Yeah. Let me repeat. When you convert a binary number to a decimal, you start from the right. You use a digit, each digit at each position to multiply the power of 2. And when you shift left by 1 position, the power of 2 will increase by 1, like this. And if you total them, you get the decimal in tenth, or decimal value. Yeah. Okay, then I said try the following before you see the answer. Yeah. Anyway, you can see that for decimal, we only use 2 digits, and for binary, we use 1, 2, 3, 6. Well, yeah, but binary is easier for the computer to handle. Yeah, not that easy for us, but that is computers preferred. Okay. Yeah. Okay. Then again, we just mentioned that binary and decimal, they can be converted from either direction. So this time we are going to do decimal to binary. So you have a decimal number based on 10. How can we convert it back to a binary? Yeah. This direction is much more complicated than the other direction we have just discussed. This is somehow challenging, somehow challenging. Not too bad, but definitely more challenging than the previous direction. The idea is like this. So we have some idea like this. So here's a discussion. Suppose we have a decimal number m, and we want to figure out the corresponding binary number like this. So from previous discussion, we know that m0 should equal to this, Yeah, so we start from the right, a sub 0, then that will correspond to 2 to the power 0, and a sub 1 times 2 to the first, and we keep going until we end up with a sub n times 2 to the n. Then what? Then we figure out, if you look at this term, okay, this is, what should I say? This term has a factor 2 to the n, so it could definitely be divided by 2. So is this, because 2 to the first is 2. But the last term is a little bit tricky. The last term, because the 2 to the 0 is 1. So that is 1. So if our a sub 0 is 0, then that is fine. Otherwise, a sub 0 is a remainder. Wait, let me write it down. Where should I write it? Okay, so let's do it here. A sub 0 is the remainder of m divided by 2. So if we divide m by 2, then a sub 0 is the remainder, because all the others are like multiples of 2. Yeah. So that is what I put here. A sub 0 is a remainder of 2. So if we write this, a sub A10, I mean decimal m is 2 times some quotient q1. Some quotient q1 plus a remainder a sub 0, then we can keep going saying that A1 will be the remainder of the q1 divided by 2. Yeah. Yes. Because if you look at because if we look at this, the decimal number, and if we discard the remainder a sub 0, we can write it as so we can write it as we can factor 2 out for sure. Then this a sub n times 2 to the let's see, n minus 1 in the plus a sub n minus 1 times 2 to the n minus 2. And we can keep going until we touch the a sub 1 inside the parentheses. And the remainder is outside, a sub 0 is outside. So basically we get the idea that the quotient q1 inside the parentheses, if we divide it by 2, then the remainder will be a1. Will be a1 here. So that gives us the idea. If we keep going, like every time we divide by 2, we look at the quotient, then from the right to the left, we'll get the binary string. So you will know what I'm talking when we, what did I do? Oh yeah, I thought I closed this page. No, I didn't. Yeah. So let's look at the example, then you will know what I'm talking. Find the binary form for the decimal number 156. Yeah, equivalent to 156. Okay. Yeah. So you will see what's going on here. So first of all, we do 156 divided by 2. So it's 2 times 78 and plus 0. So the remainder, a sub 0 is 0. So we say, hey, a sub 0 is 0. So remember, that is from the right. The very rightmost digit is 0. Okay, next. This time the quotient is 39. 39. So we put 39 here. 39 divided by 2. So it's 2 times 19, and the remainder is 1. So that means, oh, sorry, I skipped this. Oh yeah, I skipped 1. Yeah, 156 divided by 2, the quotient is 78. And 78 divided by 2, the remainder is still 0. So a sub 1 is 0. Then it was what I was talking about. 39 is the second quotient, and divided by 2, it has a remainder 1. So a sub 2 is 1. And then we keep going. Every time we divide the quotient from the previous step and look at the remainder, okay? And then we organize the remainder, write it from the right to the left, Then we have the binary, equivalent binary form. It looks complicated, but actually it's not too bad. You can use a number to try by yourself. It's not too bad at all. Okay, so let's see. Okay. I include some. Yeah, so I said, you think you understand? You can try the quiz. I find that this online, it is a quiz you can test yourself if you know how to do the conversion from binary to decimal, from decimal to binary. This is not our test, but it's just for fun. If you're interested, you can try it. Yeah. Right. So far, we have talked about the binary numbers a lot. We have spent most of our time talking about, what did I do? Talking about the binary numbers and for some reason I changed the zoom and okay, now it looks normal to me. Right? Yeah, even better. Right. So far we have talked about the number on base 2, which is called binary, and how to convert decimal numbers to binary, how to convert a binary to decimal, back and forth. As I said, there are so many other choices, not just a binary. So for instance, let's just look at the number based on 7. Since you know how to do binary, then you should know the numbers on any other basis because they are so similar. Yeah, for instance, a number based on 7, a number based on 7. So we will, because this is based on 7, so we will, let me see, digits 0, 1, 2, 3, 4, 5, and 6. Yeah, you will not see 7. Just like a binary, you only see 0 and 1. For decimal, you only see 0 to 9. For the number based on 7, you only see 0 to 6. So keep this in your mind. Right, so let's look at the first question. How can we convert 2, 5, 3 based on 7 to a decimal? Again, this is very similar to what we did. We start from the right. 3 means 1, so 3 times 7 to 0. 5 means like 5 tens, but here tens means the power of 7 is 1. And the 2 means the power of 7 is 2. Huh? So 2 times 7 squared. We organize them together, we get 136. And the next question, find the decimal number which is equivalent to, this number is based on 9. So don't get panicked. It's exactly the same algorithm. You start from the right, again, for the number based on 9, you will only see 0 to 8. So we start from the one on the very right. So 8 times 9 to the 0, plus 6 times 9 to the first, 0 times 9 squared, and 1 times 9 third. You total them. It is 791. Again, you can pause the video anytime. And if you need to try these problems by yourself, we need more time to digest. Okay. So we have seen numbers on different bases, and we realize that the way to convert numbers of different bases to decimals are very similar. And the backwards operation is also very similar. Convert, let's see this example, convert the 245 decimal to a base 5 number. Remember what we did before? We always divide by 5 and look at the remainder. Yeah, before it was 2 binary, so we divide by 2 and look at the remainder. Here we follow exactly the same idea. So 245 divided by 5, the remainder is 0, so a sub 0 is 0. And the quotient is 49. So 49 divided by 5, the remainder is 4. So the next remainder is 4. And 9 divided by 5, the remainder is also 4. So 4 is a remainder. And the next one is probably the confusing one, because this time the quotient inherited from the previous step is 1. Huh? So that is the most confusing one for many students. But so what? 1 divided by 5, the quotient is still 0, so the remainder is 1. Yeah. And then we write from the right to the left, so the answer is 1440 based on 5. 1440 based on 5. Yeah. Okay. So we are done with this problem. This should be okay. Just some calculation. Some calculation. Yeah, so I just designed more problem like based on 9, converted to base 10. So you can read that by yourself. As I said, they are so similar. And I think you already know how to do it. So I'm not going to repeat the problem. The process is so similar. Okay, I hope you enjoy this topic. As I said, why people are worried about, especially the binary numbers, because of the computer. It's all about the computer. The binary numbers has such a wide application in the information area. And since the base 16, 16, and 8 are all powers of 2, so correspondingly, the octal number and the hexadecimal numbers are also widely in information system, like computers, and like digit transmission. Yeah, but we are not going to go deep in that direction, because we're about number system only. Yeah. Okay, so that's it for this class. Different numbers on different bases, and you can look the corresponding part in your homework now. If you have any questions, just let me know. Bye, see you soon.